Crime. So I'm Rob Sherwood, CTO at Big Switch Networks. From my experience at previous Network Field Days, I will try to suck in my gut a bit. I don't know if the Network Field Day camera adds more pounds than a typical camera, but and we have three. Maybe that's what it is, multiple cameras. So I'm going to first talk about kind of our architecture and vision to give you kind of a general view of how our products work before deep diving into both products. We've actually chunked this out, as you can see in the agenda, into different sections. So. As Prashant mentioned, we believe that we have seen a complete change in how the thought leaders of networking are doing networking. So there are Google and Facebook who have built their own switch hardware. There are companies that are building their entire network stack themselves. There are people who are basically reinventing this entire stack. Why? These companies are not trying to build you products to sell to you. They're not trying to compete with the likes of the incumbent vendors. They're doing this because the network is in their way. Facebook and Google are, for all intents and purposes, advertising companies. They don't care about the network except for the fact that it's actually inhibiting them from making more money. That's why they've started doing this. It is a tacit assertion that the incumbent vendors, the products that they build, do not work for companies at this scale. So that's kind of crazy. I mean, I've been in networking for a while. I think you guys probably been in networking for a while. To have the biggest, most scale out, most complex networks in the world go, yeah, what's off the shelf doesn't work for us. That's a completely new kind of earth-shattering thing. So what does Big Switch do? Big Switch says, that's actually really interesting, but because those guys won't productize this stuff for you, that's what we're going to do. We're going to learn from these people, find the things that work for the rest of the world, to separate from the things that don't work. So there's a bunch of stuff that they're doing that's very, hyperscale, customer specific, and try to productize that. Try to turn that into something that the average person can consume. And by the average person, I don't really mean like a mom and pop shop, but a Fortune 1000, Fortune 2000 type company. Specifically, if you start looking at this, so the hyperscale folks, they have massive, massive scale. My guess is that most of the companies you work for, most of the companies you consult for, don't own multiple football-sized data centers. That's not to say that there isn't technical and operational benefits from going to a modular scale-out architecture. Having a customized per application solution is probably something that scale doesn't make sense for most of your customers. But having a mature out-of-the-box solution that you don't have to cobble all the pieces together yourself, but still leverages some of these things, that's very valuable. And you can kind of go down the line and say, all right, well, Google and Facebook do their own development. Okay, we need to provide support for them. This white box thing, this whole bare metal open networking thing, that's real. I call that harsh economic reality. Basically, what's happened is, because there are so many boxes being built, it makes sense from a financial perspective to have very specialized companies like Broadcom that only make the chips. So historically, like a networking vendor would be wholly integrated, meaning that the company would make the chips, they'd make the box, they'd make the software that goes in the box, they make all the management around that software. And that model has become so successful that you've actually have specialization among the different layers. And so you get companies like Broadcom who basically said, all right, well, we can build better networking chips than anyone. And you don't have to believe them. You can turn around and look at Cisco, Juniper, like basically everybody ships boxes based off of their chips. So for all intents and purposes, speeds and feeds, the thing that used to always drive like buying a new box, is now a non-issue because everybody's buying the same chips. Everybody has the same speeds and feeds. How many data center switches that have 48 by 10 gig and 640 gig uplinks? Because they've got a Broadcom Trident 2 inside. How many people do you know have on their roadmap a 32 by 100 gig box? Because they've got the next Broadcom chip coming down the line. The speeds and feeds, the actual base packet forwarding, is effectively now commodity. And of course, the support's definitely an issue. The rest of the world wants a single throat to choke, and that's what Big Switch provides. Yes, we put the software on the box. We put the software on other people's boxes. We don't produce boxes ourselves, but we still provide that same support experience that customers know and love. Now, I'm going to stop here obnoxiously, and I know that you guys have said nothing so far, and that's completely counter to your intuition. Now, either I'm speaking too fast or we gave you too many burritos, so somebody has to ask me a question.
Burritos with fries.
Just before going any further, Big Switch solutions are focused on the data center, right? We're not talking about white boxes and branches.
Yes, although I put an asterisk on there currently, but yes. Great talk. How many of you know who Amin Vadat is? He has a title that's reasonable, but I call him the grand muckety muck of networking at Google. He gave a great talk at ONS. I recommend you check out the link. But basically, he said, we learned a lot in deploying our own networking. This is what the talk it's well worth looking at. But the highlight is, he said, we learned to use merchant silicon, we used to use centralized control, and we learned to use class topologies. And so, all of Big Switch's products use merchant silicon. We use centralized control. We call it SDN. And we build class fabrics. And so, what do? So, we take other people's switches, either ODM manufacturers from Taiwan, folks like Dell, other people potentially coming down the line, and we put our software on top. We put our operating system on the switch, but that's actually a stripped down operating system. It's not the heavyweight operating system that you're used to. And we pull a lot of that control plane functionality and pull it out to an external controller. And we actually have 2 versions of that external controller, one for each product that Prashant mentioned. So that's what it looks like with one switch. What I want to convince you of is that there's actually a shared interesting architecture between the 2 products that I call the one big switch architecture. So if you look at like a traditional chassis-based design, and you kind of look inside for how it's implemented, there's like 3 parts. There's the supervisor card, which is effectively a PC. It's a PC, like a rack-mounted PC. It's a PC on a line card. There's these line cards, which each have at least one or more packet forwarding chips in it. Like on a modern box, this would be a Broadcom chip. And then they have fabric cards, which have one or more chips, maybe a Broadcom chip on it. And inside this box, like the PCBs, like the actual motherboards of it, like the wires, they connect in what's called a class topology. So what do? We take all of these same components and build it out of commercial off-the-shelf switching hardware. Supervisor card, I said it's a PC, it's a server. We run our software on it. The fabric backplane, we implement those with 1U pizza boxes, high data plane bandwidth, with the same packet forwarding chips in them. We take line cards and implement those in 1U pizza boxes that we connect up to the fabric plane. Think of this as a leaf spine fabric. We connect all the leaves to all the spines in the same class topology that existed here. And so what we have done is completely re-implemented all the features and functionality of this box using standard hardware. Nobody has any questions. I want a do-over. Does this just make too much sense? All right, well, I will continue to say more ridiculous things until somebody asks me something. I'm being let down here. So we believe that this trend exactly follows the trend how mainframes eventually were disaggregated down to racks of computers with basically commodity hardware and smart software. This is the same trend that the network's going to go down to the point where we've now started internally jokingly calling these net frames. These are just like the mainframes of the world, but they're going to get disaggregated down to 1U DC data center switches, collectively managed like one big switch. You don't have to log into every switch to manage them. Just like you'd log into a supervisor card, you log into our controller.
I like how it looks like net is written in blood.
Yes. I did that. It was supposed to be spray paint, not blood, but maybe I was projecting.
The blood of our competitors.
But does this make sense as kind of an architectural trend? It's almost to the point where, so I don't know if you guys know the design detail, like the internal details of how you build these boxes, but inside these boxes, they actually have Ethernet networks for the control plane. So when the supervisor card actually talks to the line card, like if you log in and configure a route or you change an ACL or something like that, you're logging into the PC that's here, And when you execute that command, it's actually got an internal protocol that updates all the line cards and updates all the does all the things that need to get changed under the covers. And I call that protocol closed flow, because it's exactly the same thing that we use OpenFlow on this side for, and there's functionally no difference between it. Really no questions so far. No more burritos for you guys. That's
Can you talk more about the functionality that exists on the switch versus in the controller?
Yes, although what's fascinating is it actually follows exactly the same paradigm that you would have here, which is to say, where do you implement a BGP daemon? So what ends up happening is, exactly what you do here. You would have a user space process that handles all the BGP traffic, but some of the functionality, like if you send an ICMP echo request, what's the thing that generates the echo reply? It's actually done on the line card. Like that doesn't get punted up to the supervisor card. And so exactly like that, we implement the same thing here. And I'll talk about this later. There's a bunch of functions that get offloaded to here. And there's design decisions about whether we implement something on the controller or the switch, but they're exactly the same design decisions that happen on the left side.
So the list isn't maybe as narrow as it was 2 years ago or a year and a half ago. It's expanded, I guess, in terms of what you're offloading to the device.
Exactly. And so we call this, instead of, I think people have been pushing centralized control. We call this a hierarchical control model, because really there's actually a control plane local to the switch, much like there's a control plane local to the line card. But then there's also the control plane on the controller. And depending on how global versus local, or how complex the operation is, there's a design trade-off for where that gets implemented. And I'm happy, and I'd love to talk with you guys about that, but the high-level bit is it's functionally the same design trade-off that you have working in your network right now. It's not, to the point Prashant was making earlier, this is really, while it's a complete revolution from to be able to say, all right, well, now that I can put software on here, here's the list of features that you could never do with your traditional command line interface. Or here's the things that never worked for you because you've been managing your box by box, managing your network box by box. So it's a complete revolution from that standpoint. But in terms of how the actual low-level packet forwarding happens, it's the same thing that already exists in your network, just without the sheet metal.
How do you handle unknown unicast and broadcast traffic?
Same way. So basically what happens is the controller, before any packets are forwarded, programs the non-unicast policies and the flooding policies and everything like that into the chip. So for, say, like a destination unknown Ethernet message, that actually never leaves the chip that it goes into. Like if it's local to here, so think of it as the separation of the data plane and the control plane. That's a non-control plane message. And it's exactly the same as what's here.
And to be able to have a piece of the control plane on the switches is important, and that's why we insistently call it hierarchical implementation of the control plane. Much of it is centralized, but there is a bit that is distributed. And when it's distributed, we get the benefit of scale and resiliency. We can populate, all the tables of Broadcom. There is not that there's limitations. Tens of thousands of MAC addresses, IP addresses, ACL tables, QoS, everything is at the disposal. The other is that you get the headless operations. So both controllers can be offline, and the network continues to function. And these are the basic principles of networking that one needs to adhere to, whether you're SDN or not. And I think that's sort of the reason why control plane has been implemented in this hierarchical fashion.
Does it?
I think the reason nobody's asking so many questions is this concept is, I think, becoming generally accepted, that if you're going to scale out and you're going to have fast, centrally controlled data centers, you've got to build out a closed fabric. So,
Yeah.
So are you going to get to how they communicate, how they learn MAC addresses, all that? You're going to get to that.
I'll get to that, but more importantly, to your point, this is becoming generally accepted. What I'm actually going to spend most time on is, given this, what are the cool things that we can do on top that other people don't do?
In other words, we are using the same principles
Yeah.
of normal networking. So, just that it's represented differently. I mean, supervisor is a centralized control plane within the chassis. And all of the principles we have learned over the last 15, 20 years of building chassis architectures are simply extended, except the components are spread around, and hardware could come from one vendor and software could come from another vendor. So that's the change that has happened, not the underlying networking principles.
So given that, you can think of our two products as basically, we took a big switch that existed in the network, we broke it out, implemented it with commodity 1U data center switches, and ran different software on the top to implement different functionality. So our first product, Big Monitoring Fabric, used to be Big Tap. You guys have to keep me honest, we just made the name change, so I'm going to slip up. We take a network packet broker. If you guys don't know what that is, honestly, a lot of people don't, but it's a really useful part of the network. I'll have an entire section to talk about it. And we take that big switch functionality and we implement that with still a single point of control with many smaller 1U data center switches. And there's benefits both on the software side as well as the scale out side for how to do that. We also do the same thing with a stock data center switch, which is to say, same hardware, completely different control software. I shouldn't say completely, there's a lot of overlap, but different control software. We implement data center switching. And what excites me, and one of the reasons why I love working at Big Switch, is these are the first two switches that we've decided to implement with commodity hardware. Other things are possible. Questions, comments?
Did I hear you say that there are two separate different controllers for Fabric or monitoring?
They are productized. They're basically two different products. Internally, they actually share a lot of code. Like if you look at the look and the graphical user interface, the user experience is very similar, but the base packet forwarding policies are completely different. But what's cool is you can implement it on the same hardware.
So that was my question. If I wanted to have both functionalities, would I need to run?
You can't. So one switch can only be in one mode or the other mode at the same time. Basically, what it works out is the Broadcom chips have a bunch of global settings. And so it's kind of like trying to run Linux and Windows on the same x86 without a hypervisor. Quickly, our Switch Lite OS, in addition, it's not just a fun name. I mean, it really is a stripped-down operating system. It's basically a stock Linux distribution with an OpenFlow agent. And it's actually so stripped down that everything besides this purple part here, we've actually pushed into an open source project that I call Open Network Linux that I'll talk to you guys towards the end if there's time.
Downstream hardware, you support Broadcom, Trident 2.8, right? And then what else? Do you have a comprehensive list?
So on the chip side, it's Broadcom. For Big Cloud Fabric, it's only Trident 2 currently.
Okay.
For Big Tap, it's Trident 2, Trident Plus, and there's some 1 gig chips as well. But actually, the dominant thing for us, and it's one of those things we take for granted with servers, is there's actually a fair bit of work to port from different switches, even though the chip is the same. Mm-hmm. Right. So there's actually new software that we have to write to move from a Dell switch to a Quanta switch to an Acton switch.
Do you do anything with OpenFlow TTPs to make that a little simpler?
No, and in fact, OpenFlow TTPs is a longer conversation. I don't believe that they accurately or can accurately reflect everything the Broadcom chip is capable of. In fact, usually when we try to get a new feature into a product, we have to sit our Broadcom experts down with a whole bunch of people who do some testing, and it's a hard problem for very smart humans to solve. I don't think that computers will be solving that problem automatically anytime soon.
Okay.
Last thing I'll say on this, and it may be the most important slide. Hopefully you guys have heard this before, because I think we prepped you for this, but for those playing at home, we have both products actually online for you to demo and play with for free. So if you go to labs.bigswitch.com, you can actually just try both products in a virtual Amazon EC2 hosted environment. The switches are virtual, but it's actually our real controller software, and that's really the thing you'd be interacting with.